Hello, hello. Welcome, everyone. How to create AI agents that don't suck. This is the title of the workshop we're doing with Alex Reibman. I don't know how to pronounce your last name, but we'll look into it. Founder of Agent Ops. He's supposed to be with us here today, right at 11:30. Um, Assuming he's busy, he might send an agent that doesn't suck to join the call. So we'll just try to buy some time till they can make it. This is part of the workshop for the Be Loud and Build hackathon, and I'll pass it on to Bahar.
Hello, everyone. Hi, I'm Bahar. I'm co-founder of BeLoud. Poria is also a co-founder of BeLoud. He forgot to introduce himself. And as Poria mentioned, we are hosting the loudest, biggest AI hackathon, which is global, virtual, and hybrid this week in 2 days exactly. And you have a little bit of time to register. There is not enough time left, but you still can register right now. And we will share more about it, and I'm just waiting for other people to join in slowly, and then we can start the presentation.
Yes, so this is a live stream going directly to LinkedIn, YouTube, and Twitter. Pick your poison. If you do want real-time chat, Twitter is your best option, and we could see all your comments over here. Some people said the registrations were closed for the hackathon, so we did open it up to a few more slots. If you do want to join, go for it. There are 2 in-person locations, possibly one more in SF, which we're confirming today. So we got Vancouver, Canada so far, London, UK, and quite possibly San Francisco in the Bay Area, and also virtual. But the catch is, if you do want to participate virtually, you need to have one person physically in one of the locations. So either in Vancouver, Canada, in Vancouver, London, or possibly SF, which we'll confirm. And it's one of those new experiments we're trying out, right? Every single hackathon that I participated in 2 hackathons, 3 hackathons so far. Never hosted a hackathon, so it's the first time for everything. But a common theme that was going around is how do you gamify the hackathon? How do you get people to be more engaged and make it more inviting? Something new we're trying is figuring out how to live stream from day 0 to day 3 of the hackathon full on, like from when people are pitching their ideas up on the stage, virtual or in person, going around with a going around with a Rode mic that we got from Amazon, which was supposed to be delivered today. I hope they're not late. And we're gonna go around, interview them. We got a big rake that like has a light and some mic that you can go around and interview people. So we're gonna do that for the pitching day on Saturday. Do the co-working hacking, where teams are in pods of 2 to 5 and going around to see what they need help with, what idea they're working on. Is it a $1 billion idea? Who's like the CEO, the web person, the coding guy, the content creator, and also share about their project live upon the stage.
Yeah, as Poria mentioned, we are using a very cool platform called SoWork for everyone who's joining us virtually. It's literally like Sims, and you will be interacting and co-working together and joining the sessions and the workshops and having office hours all in that gamified game scene. And it's so interesting. You can search it up right now, but you will all have access to it, and you spend more than less than 3 days of your life there for in next two next 2 days. Also, as Pori mentioned, we have an emphasis on building a product that they can find users for it in 3 days. As you know, there are a lot of products out there that have very good backend and front end, but the problem is that they don't have any users, and that's as if they don't exist. So it's really important to find users. For that reason, we are inviting content creators and creatives and designers to join every single team and help you with the exposure and creating content about the idea you're working on the day one. In these 3 days, you're either going to build a startup or you're going to fail really fast at something in just 3 days, which both would end up be good. And I tell everyone that what you can accomplish in 3 days, outside of these 3 days, it will take you 6 months to either accomplish it, execute it, or learn it. So it can be a good thing.
Yeah, so I just tagged Alex in the chat. Okay, Alex trying to join the call but doesn't have the link. Okay, I will email you the link, Alex, if that's okay. So as Bahar mentioned, one idea to an MVP to a user. Part of the reason we started this is that within our network and the stuff we were seeing, a cool thing like this wasn't happening. Secondly, we saw an interview that Sam Altman did, and he was saying that a small team, you can make the next $1 billion startup using AI. And we were like, come and do it in 3 days. Like, let's challenge you to it, and let's show the world the power of AI as we push the boundaries all in together. So the theme is build in AI or using AI, fairly general, just so you could understand that it's easy to like. Well, it's not easy, but doable to like make a product and find a user for it in 3 days. And people have done it before in hackathons by AGI House, I think, either the OG one or the not OG one. Um, and other hackathons before, so it's totally possible. I was talking to this content creator who had like 100K ish, 400K followers on Instagram. He's like participating in the hackathon as well. He said, my goal is to go from one idea to an MVP to being acquired. And he was saying that's ambitious enough. I'm like, dude, we could totally like help you with that. So part of the reason why I reached out to WeFunder, want to reach out to acquire.com founder, and if they're watching this, which I don't think they are, but I'll reach out to you. We do want to put like their funding page on the live stream on the spot. So if people from the public like to support their project over there, they could just like transfer the money and stuff. It's gonna be quite fun. We're super excited for it.
That's great. I think it will take a couple more minutes for Alex to get here, and we can start a presentation. What do you think, Puria?
Sure. Yeah, we could do that. I just hope it's the real Alex showing up, not his agent. Which at this point I'm assuming it could be both, but we'll see. Go for it, Bahar.
Awesome. So as you know today, oh, it's great. We have Alexis here. So we'll invite him first.
Okay. Can you hear me? Am I in?
Yes, we can hear you. Welcome, Alex. Okay,
Amazing.
just to confirm, this is the real Alex and not Alex the agent. Okay, perfect. So yeah, we're just trying to kill time, and we're telling people about the hackathon. We're super excited to partner up together on it, and we're gonna do like a brief 1 minute thing about Be Loud and the hackathon, and then we'll pass it on to you. Sounds good? Okay, perfect.
Awesome. Welcome, Alex. So happy that we have you here. Hello, everyone. Thank you for being here. Thank you for Alex the time he's spending. It was so last minute. I love this fast speed of setting up things. So thank you so much. It's so different from other companies and organizations, and I love that. Thank you for everyone who's been here. It's 11:40 a.m. in the morning on a Wednesday, Thursday, and it's really I'm so thankful for being here. I know you might be busy, have time, have things to do. So a little bit about what we do. Be Loud is a non-for-profit organization. We help startups go from zero, finding their next 10K customers or raising fund. We have a community of founders, builders, creators, and investors. In the accelerator, we help startups to grow. In the studio, we help startups to be built up. And then we host workshops, events such as the hackathon, workshops such as this, like almost every week for the community. We're on a mission to onboard the next generation of creators, builders, and investors on it, shaping the imagination age and into the imagination age. But what is imagination age? If you remember, the time of emailing and texting was a kind of a thing. It was getting popular. The time of Facebook, all of that is in information age, and that's in the past. Right now, we are in the imagination age, the age of AI, Web3, AR, VR, OpenAI, ChatGPT, all of these cool technologies that are giving us abundance of access to resources to realize ideas and to make things done. So we thought now that you can go from prompt to anything in matters of seconds, why not test this and see if you can build $1 billion startup in 3 days? And you're not going to be alone. You're going to have team members from diverse backgrounds, someone from marketing, someone who's a developer, someone who's a designer. And we're trying to create this environment for you to be able to create this $1 billion startup. So we started working on Be Loud and Build AI for less than 2 months ago. And we are here now with Alex. And please join in. If you have friends, colleagues who you think might be interested, invite them. It's going to be fun. It's global, virtual, and in person with 2 on-site locations, one in Vancouver, one in London. And we are so excited to see you there. Now, we also have hosted events before in Vancouver. If you're in Vancouver, join us in person as well. Most of our events are both in person and virtual to be more accessible to everyone and the community. And thank you for being here. You can follow us on socials, Be Loud XYZ, and we have Alex here. The stage is yours, and thank you, everyone.
Okay, awesome. So I am going to figure out how to share my screen here.
At the bottom of the screen, there's that plus button, and then we can add it to the stage. Quick notes again. Thank you so much for coming, Alex. We literally set this up last night at past midnight. I don't know if you stay up too much. I don't usually stay up tonight, but thank you so much for doing it.
Listen,
I'm super
it's hard
excited.
to sleep when you're in such an exciting field. So
Yes.
I'm always happy to tag along and do this kind of stuff. So
super agree.
Cool. So I will kind of give the brief or the high-level overview. Yeah, about myself. So my name is Alex Riedman. I am one of the founders of Agent Ops. So Agent Ops is an observability, testing, and debugging platform for building AI agents. So what exactly does that mean? So what exactly is an AI agent? This is the question that everyone's been asking. Sam Altman was talking about it. Bill Gates was talking about it. What's going on with AI agents? Well, they're really popular for one. So kind of like early last year, there's a project called AutoGPT, and it rose to become one of the most popular projects ever on GitHub. Like, I think in the span of a few months, it had like almost 100,000 stars. It's well over 100,000 now, at least. And the idea was, what if you took ChatGPT and you give it the ability to program itself and build itself out? So like really turning a large language model into an autonomous program. There were some other projects that came out of this as well. So there was Jarvis. Jarvis was an idea by Microsoft, which is like, it would kind of be like an internal AI assistant, kind of akin to the one from Iron Man, I think. And probably the most popular one that everyone's heard of is Baby AGI. So Baby AGI was actually a project by this guy, Yohei Nakajima. He's a hobbyist developer. He's actually a venture capitalist full-time. And he developed Baby AGI, which is, the idea is you give an agent a high-level task. You say, hey, I want you to find cool hackathons in San Francisco, or tell me about Be Loud, right? Or search the web and do whatever. And what it does is it actually constructs a task list. And with that task list, it will try to execute tasks using large language models and vector embeddings and a set of tools. And these were like in the very, very early days. This was probably March, right after GPT-4 released. That was March 14th, 2023. People started playing around with the stuff, and it really blew up. So the idea is you don't just have like regular LLM calls and RAG apps anymore. You actually have self-driving programs. So the simple analogy, and I use this to describe agents all the time, is like we have software for self-driving cars. We have Zoox, we have Waymo, we have Cruise, so on and so forth. If you're in San Francisco, you see these things all the time. If you're in other parts of the world, they're coming, I promise you. But now we have this idea of like a self-driving program. And you have the AutoGPTs of the world. You have Devin, a self-driving software engineer. You have Lindy, which is kind of a self-orchestrating executive assistant. And kind of the broader thesis here is that or at least the way that we think about it, is the 90% of programs in the next decade are going to be autonomous. They're not going to be written by a human. They're going to be self-orchestrated. They're going to be self-designed. And they're going to be fundamentally changing the way that we interact on the web, which is right now we have APIs, we have developers, and developers talk to APIs. But soon you're going to have agents. You're going to have developers talking to agents, and then agents talking to APIs, and then agents talking to agents. And it's going to be this whole new construct to the point where the way that we think about computing as kind of a standard service-based approach is going to be totally different. So just, this is kind of aimed at being a little more high level and for folks who are a little less into the agent space. So I'm going to show off some examples of some really cool agents. So there's a paper that came out last year, and I thought this was really mind-blowing, where a team at NVIDIA created an agent called Voyager. And the idea behind Voyager is it actually was a simulator for the game of Minecraft. So in the game of Minecraft, you were a blocky character, you go around a blocky world and you explore and you hunt creatures and you craft items and you mine things. And the way that this agent was constructed is all being powered by GPT-4. And what they did is they gave it the ability to teach itself skills. So you could say you give a player in the world and it knows nothing, but it has a high level objectives like fighting enemies or crafting items or mining for resources. And it would actually iteratively write its own code. And if the code was successful and if it was doing a good job, it would save that code to a skill library. And that way, when the agent was in the same situation again, instead of having to think and reason and design its own code, it would actually just pull a skill from the skill library. So if I gave it the task of starting a campfire, instead of thinking step by step on how to do that, it would say, oh, I need wood, and I already know how to mine it or chop down a tree. So I will take that tree and then I will make a campfire out of it. Or for fighting a zombie, it would say, I know how to fight zombies. I have a sword in my inventory. I will use my skill for creating my sword and then use it to fight the enemy. And what this ended up looking like, this little video here, this is the agent in action. So this is entirely autonomous. There's no players playing this whatsoever. It just figured out how to play all on its own. So what we're seeing here is like these emergent behaviors of basically, again, self-driving programs where they're able to navigate the world and solve problems and solve puzzles. And it's really remarkable. It's like, okay, yeah, it's able to play video games, which is a simulation for the real world. Now, just imagine 10, 20, 30 years in the future when we have the actuators of the robotics that are actually good enough. We might actually have autonomous robots being able to maybe not fight enemies, but maybe chop down wood for us, right? Or starting campfires or mining for resources. And this is where we start entering kind of like this futuristic age of Blade Runner and all this kind of stuff. There's all sorts of philosophical discussions about it, but we really need to think like this is a glimpse into the future of what the next generation of technology will look like, which will be AI agents. So anyway, that's enough of watching Minecraft, but kind of a conceptual level, and there's a lot of like thought leadership online about this, but a lot of people have been thinking like, what is kind of the next abstraction beyond basic computers looking like? So we all think about, we have CPUs and GPUs, we have storage, we have, networking cables, so on and so forth. Andrej Karpathy, like legendary ML researcher, thought of like the LLM OS, which is like your new CPU is your large language model. And your memory is basically a combination of how big is your context window. So how many tokens or how many words can you fit into ChatGPT's prompt interface before it runs out of memory? And then, sometimes you want to extend the memory, right? So you can actually have extended vector databases for this kind of stuff. So you have a disk storage, which is like file systems, embeddings. You can give it Wikipedia, so you don't have to tell it to memorize Wikipedia internally. But kind of more cohesively, what you want to be doing is adding tools to your agent. So the ability for your agent to have actuators to actually interact with the world in some sort of way. And that's where things get extremely powerful very quickly. But the limiting factor here is actually going to probably be at the large language model level. We don't know when GPT-5 is coming out. A lot of people are theorizing it's going to happen next month, so prepare your business. But the thinking here is that if you're able to create a powerful enough CPU for your agentic program, you can build some really cool stuff out of it, like self-driving programs. So this is kind of like a high-level view of like what agents are, like from a diagram level, and I'll break this down to like more and more granular details over time. So kind of encompassing this idea of an agent, you have number one, first and foremost, you have tools. So the ability for your agent to actually do things is what makes it an agent. ChatGPT by itself isn't really that smart. If I ask ChatGPT, who is the president, it will probably know the answer to that, right? It's just baked into the weights of the model itself. But if I ask ChatGPT to buy me a pizza, it will not know how to do that, right? It doesn't actually have a way to interact with APIs, to make phone calls, to send emails, to use credit cards. When you give it these tools, and you could define these tools as basically user-defined functions, you say, hey, ChatGPT, I know you're bad at math, but I want you to multiply these two prime numbers together, give me the result. Instead of actually trying to guess that number, which is what it does currently, you can just say, hey, use the calculator tool. Or, hey, ChatGPT, can you write the Fibonacci sequence for me and resolve that it runs? Instead of guessing, the string's guessing itself, you can actually use a code interpreter tool or a search tool, so on and so forth. We're able to kind of extend this. There's some theory about like infinite context length window models. I don't think that may or may not happen. We'll see. Maybe GPT-5 will really blow us away. But for the time being, there's like a lot of hacks around it, which is like we have the disk storage, we have vector database, Pinecone, Weaviate, so on and so forth. Highly recommend checking these out if you want to save documents in embedding space and then basically use them for retrieval so that you can enhance your responses. And then around that, just encompassing like what the agent does is like it has the ability to create actions. So it's not just like predicting strings, but like actually triggering some sort of function to enact those tools, which is a challenging model by itself. So actually like a lot of folks are specializing. There's a lab at Berkeley right now called Gorilla. They are specializing entirely just on building models that know how to read prompts and decide which tools to pick. So this is a very, very large component coming out soon. Secondary to that, and this is kind of last, is the planning mechanism. So planning is the ability for agents to actually think through problems. By and large, LLMs, like, you know how there's like little hacks where you say like, hey, think step by step to solve this problem and it performs a little bit better. Or sometimes you can offer it a tip, say, hey, ChatGPT, I will tip you $300 if you do a really good job. Or ChatGPT, my grandmother is going to die unless you solve this task for me. And then you actually inch up the accuracy and improvement of it. That's actually like what the planning stuff is. So it's like not just like, you know, prompt engineering, prompt smoothing, but actually sometimes giving it a task list, giving it critics to actually criticize its goals and make sure that it accomplishes the way you want it to. And then also giving sub goals and decomposing those goals, so on and so forth. This all actually helps the agent reason through problems, use the tools that it has at its disposal, and solve the problem that you could throw at it. So here's kind of like the mega diagram, right? So what components does an agent actually have beyond these kind of four core mechanisms? So underlying it all is your large language model. By and large, if you're building an agent right now, I implore you, please pick the best LLM, which is going to be GPT-4 in 99% of cases. I heard Claude is getting up there, but GPT-4 is going to be the best tool for most circumstances. The reason why is LLMs are becoming commodified in a way. You have a bunch of big providers, and they're all kind of like, the asymptote is that they're all going to be the same. In the same way, we don't really care which gas station we get our oil from. We're not going to really care which provider we get our tokens from. So just think of it like right now, like pick the best oil for your car, which is GPT-4. And then you can worry about smaller, cheaper, local models later on after you prove these things work in production. And honestly, it's only going to be a couple of years where everything's kind of more or less the same. So just work with what's best, right? It's just swapping out a string at some point. I'll work from the bottom up so that we kind of have a high level description of what's going on. So the biggest idea is like having a workspace for your agent to execute in is probably one of the most important things. Agents by themselves, like again, like the reason why I chose this little like creature here, this is actually kind of a mythical creature called a Shoggoth. And the idea behind a Shoggoth is that it's like a Cthulhu-like creature that is developing the tools that orchestrates the end of the planet. But we have a little smiley face on it because that's what reinforcement learning through human feedback does, which is like it aligns the model in some sort of way. But these things are actually quite dangerous, right? If you tell it to buy a pizza, how do you make sure it doesn't buy 500 pizzas? There's a famous case where they gave an agent access to a terminal and said, hey, agent, I want you to please delete every JSON in this directory, every JSON file, and it deleted every JSON on the user's computer. So these things can be destructive if you're not careful. So being able to sandbox, containerize your agents is really tantamount. There's a few tools for this. Number one, you can just open up a virtual machine, right? And just put your agent in there, sandboxing it. Secondary, there's a great tool kit called E2B. That's the letter E, the letter number 2, and the letter B. And they basically have like a containerized environment where you can just give your agent the ability to perform actions so it doesn't do anything destructive. Now with that, agents themselves, like I think agents is kind of like the name of your app. Like we call agents apps agents these days if they involve large language models. But oftentimes you end up having multiple agents working like in concurrency with each other. So I'll go through an example later. We'll actually do a code walkthrough. One agent might be like writing a job description for a job, right? And so what you have in there is like an agent that does research on the web, and then an agent that summarizes the results, and then an agent that writes the job description, and then an agent that is an editor and basically figures out how to compress the research you did into kind of a small text sentence. And that's where you have the multi-agent tenancy thing come into play. Major reasons behind that is, number one, it's a little bit of a hack. Number one, it gets around context window limits. So GPT-4 Turbo has like 128,000 tokens, which is actually not enough for like a lot of tasks. So being able to kind of parallelize these agents actually artificially lets you expand your context window. There's obviously trade-offs too, but having more agents actually does the job better. Also, you can parallelize the tasks. So you don't actually necessarily have to wait for one to complete before the other one executes. You can have them work concurrently, and then that way you save a lot of time during the execution. And just one big complication here is that agents are very slow. So anything you do to cut off seconds is a very big win. In terms of actions, one very important thing that you want to do is be able to actually know what your actions are doing. Creating an audit trail of how your agents are actually interacting with the world is useful for two very important reasons. Number one, debugging. What you're going to find is that agents right now are very unreliable. So being able to just see the paper trail of what your agent does it's a huge win for debugging. Second to that is being able to have like an understanding of like what tools your agents are using. So for example, if you give your agent access to a very expensive database that it never uses because it never needs to use it, you can probably cancel that subscription, right? So being able to see which tools it uses is a big win. Planning manager, I'll go into that in the next few slides. External memory, there's a few kind of like interesting thoughts about this. Again, like I mentioned a lot of vector databases like Pinecone, Weaviate, so on and so forth. But I actually really recommend, instead of just like, using these databases, think about like what the purpose of the vector databases is. Oftentimes they're used for RAG applications. So being able to retrieve documents, put it in context and summarize it. But this is just like a convenience way to search through things. You can easily replace a vector DB with Elasticsearch. It wouldn't be the easiest, but vector DBs, they're basically just a way of retrieving more tokens for your model. All right, so we're almost done with this bit, but understanding how your agent uses context is very important. So one major important complication with these agents is that the more tokens that you actually load in the prompt, the less accurate they get. So just understanding how much tokens that your agent is using will actually be important towards like measuring the accuracy. Think about it like this. If you have an agent that takes 20 steps and the agent is only 90% accurate on each step, by the time it reaches the 20th step, there's probably going to be a high likelihood that it's veered off course at some degree. So you want to just like be careful to like make the agents very, very as confined as possible, and managing your token usage and your context usage is going to be a huge one going forward. Tools, functions, talked about that before. There's a lot of different tools you can use. Just imagine any user-defined function you can write in Python. That's basically what you can do. All right, so with that said, so kind of on the metadata side of things, when you're developing kind of an industrial grade agent, right, you want to be able to tracking all of these things. So the session ID, like what exactly was the context that your agent had when it was running? So what permissions did it have? Who were the model providers? How much budget did you give it? Which tools did you give it? What was the system prompt of your agent? These are all like major considerations to think about and just like tally down before you just start building. It's like, okay, how do I make sure this thing's not going to cost me $80 in runs? We've had some users that spend $20,000 like a month on GPT just because of how expensive it is. So keep in mind, like, there's restriction you want to add and just track to your agent. The tools themselves, like number one thing is like giving it a list of functions that are able to call APIs is probably the biggest thing. And just being able to manage that list of tools is like a huge win for you. And it helps you understand like how do you prioritize which tools are the most valuable for your agent, and also which function calling algorithm is your agent going to be using. Second to that is I just want to mention this, like a very, very big thing is that code execution is probably one of the biggest use cases for AI agents right now. So being able for agents to basically read, write, execute code, use its own code interpreter, so on and so forth, is going to be a massive win going forward. So just consider that like these agents are able to basically like write themselves in the way that like Voyager was, giving it an environment where it can compile, lint, and run the code is a huge win. Also, one more thing, I just want to make sure, am I still streaming? I don't want to know, have I been talking to myself for 10 minutes? Let's see.
Wait, can you hear me? Yes.
Yes,
152
okay, we're
people
good,
are
right?
watching this live. Yeah, so you should be good.
Okay, I had this huge fear that I might have just been talking to myself for 20 minutes. So
No, you have not.
glad that I'm
Even
not.
if so, that's okay. That's the beauty of it.
Okay, I do that enough already. So all right, we'll go back to the big laundry list, and then ultimately what I would do is show off a few more charts and run some agents, right? And by the end of this, we're actually going to build an agent ourselves. Should be super simple, and we'll take it from there.
Nice. Sorry, Alex, what type of agents are we going to create? Do you have like a specific use case you want to cover?
Yeah, we will be doing an agent, and I will post a link to the repo in the chat. It will be an agent that, as I mentioned earlier, will actually write a job description for you. So we're going to be using Crew AI, which is an agent orchestration framework. We can actually take multiple agents and have them work together to solve a problem.
That's perfect. Oh,
Yeah.
Does this tie into Staff AI that Adam was working on? Is it kind of similar?
I will show that off just in a few slides, I promise.
Okay, sounds good.
Yeah.
Super excited.
Yeah, so what else are we talking about? So planning, we talked about planning a little bit, which is like kind of the understanding of how your agent executes things. I'll go a little deeper into that. Action history, understanding how your agent performs actions, multi-agent tenancy, we talked about that. Workspaces, LLM providers, so on and so forth. So anyway, this is just like metadata stuff. Screenshot it, or I'll share the deck with you later. Just shoot me a message. Happy to chat. Just a little bit on the planning mechanism, which is like we haven't, just to give everyone context here, we don't really have a perfect algorithm for agents yet. That is, we don't really know like the best way to orchestrate these things. And there's a lot of labbing, right? Like just be confident that like the way that we get these things to work is by experimenting, and having good evaluations and tests is how we make these things work. So here's like some common things, which is chain of thought prompting, which is instead of just asking your model like, questions and answers, you ask it to think through how to solve the problem, and that actually usually produces better results. And this is called chain of thought prompting. There's like some other things, which is you can do like self-consistency checks. You can do least to most. There's like a lot of research around this. I don't think it's like, yeah.
Sorry, are you sharing something on your screen? Because it's frozen on the PowerPoint.
Oh, no.
Is that okay?
Yeah, I was sharing. Oh, okay. Stop screen. Let me try it again.
For sure.
Thank you for interrupting me.
No worries. Someone is also asking why use Crew AI, which I think you would get into in a bit.
Yeah, Crew AI, recommended for a few reasons. It's not a no code, it's not a low code, but it's like a very simple agent abstraction that I think is helpful enough to get things off the ground. I'll talk about some agent recommendation frameworks later, but I think like anything that helps you picture like how do you create a class that has basically large language models baked in, context window management baked in, the ability to add tools baked in. It's all very simple to do with Crew. That said, like in terms of frameworks, maybe I'll just skip to the slide a little bit. Here are the main frameworks I do recommend using. Super Agent has like a great chat RAG agent framework. It's very like easy to use. But Crew AI like lets you just kind of like spin together a bunch of agents concurrently, and just like you can assign them roles and tasks. And I think just the abstraction is very simple. Another really great one I'd really recommend checking out is AutoGen. So what AutoGen does is it's also a multi-agent framework. You can create like multiple actors, but there's like different interaction patterns you have. So you can create like a chat room where your agents are all like in the same chat room, like kind of like a Slack channel or a WhatsApp group or a Facebook group, whatever you're using. And the agents all kind of listen to each other and they're able to like action based on that. And these interaction patterns actually have led to a lot of success in industry. We have some users using Agent Ops who are also building on top of AutoGen, which and they're building an agent that basically is a research analyst for a bank or for equities trading. So they're able to connect it with Morningstar and FactSet and all of their financial data sets, proprietary and licensed, and actually have to do research. They have multiple agents doing research concurrently that come to conclusions and arrive at like a good investment analysis. And they're making a ton of money with it too. So it's a really great service that they have with AutoGen. MetaGPT Cool is really cool. I'd recommend checking it out because it's one of the coolest code gen agents I played around with. We don't have time for it today, but what you can do is just give it a high level task like, hey, I want you to write the game of Pong for me, or build me an app, build me Tinder for dogs or Uber for cats. And it will just automatically, like what it does is it delegates a product manager, an engineer, a QA manager, and then a tester, and they all work together. to actually solve the task. So all really, really cool frameworks I'd recommend checking out. Things I would recommend staying away from. I'd say like anything that's like a little too convoluted. I really caution LangChain, not because I think it's bad, but I think it's because like it's easy to get lost in the abstractions. The number one thing I'd recommend doing before you even playing around with any of these tools is just play around with OpenAI in your terminal and just like figure out how things work on its own. And then that way, like if one of the frameworks solves one of your problems, I'd recommend leaning in towards it 100%. But there's not really like a huge reason to adopt any framework right now because it's also exploratory. So
Yeah.
long
Sorry.
way of saying Crew is great, but do what works for you.
Yeah, so, sorry to interrupt. So quick question for someone who doesn't know, how is LangChain and Super Agent different? Like, why would you use either or are they essentially doing the same thing?
Yeah, LangChain is, you can think of it like as a set of primitives for interacting with large language models. So what they've done is like, instead of calling OpenAI directly every single time using the OpenAI SDK, what if you want to swap it out with Anthropic or Claude or what are the other ones? AI 21 Labs, right? Or Command R from Cohere. They basically built like a simple set of abstraction patterns in Python that let you kind of swap these things out pretty easily. And on top of that, they have like in-context memory management. They have a great RAG tool. They have like a tools library class that lets you kind of add these things together. So it's like the set of primitives. They're doing some experimental stuff that's pretty cool, like LangGraph, which is like graph-based execution of tests. Again, like any other framework, I don't think it's going to work perfectly the first time. It might be the right way, it might not be. So it's all very kind of like lab right now. Super Agent is like kind of like a high level, like you can think of it like the OpenAI Assistance API, but like much more better managed and more open source. So it's a great tool. A lot of people are using that for RAG. They're selling some enterprise applications too. Honestly, I just recommend checking it out and playing around with it yourself. It's like a really cool like drag and drop tool. So
thank you. Yeah, that makes more sense because you were going through all these frameworks and tools. I just wanted to like make sure that we get it. So thank you for clarifying it.
Yeah, of course. So let's go here. Anyway, I'll just briefly touch on this slide, but anyway, the point is like there's a lot of different planning mechanisms behind the agents. For example, like the most common agent framework is called React, but it's it's kind of like outdated in a lot of ways. And a lot of people train things with like trees of thought, graphs of thought, multiple chains of thought, multiple Reacts, etc. No perfect solution right now. Do what works for you. That's the number one thing. And it's a lot of experimentation. And I wish I had a better answer, like use this, but it's really about finding what works for you, and that boils down to evals. So basically speaking is this is going to be your cycle. So this was a great post on Modal's website. So basically like the cycle for improving an LLM-based application or an AI agent is figuring out like what your LLM invocations are, logging everything, having tests for that, and then having an eval set. So an eval set basically means like, I'll come up with an analogy. So when you're in school, like a lot of people study different ways. Like, you use flashcards, or some people just cram everything the last day before the test. Some people, they study sporadically, or some people like study every single day, right? There's no perfect method here. But at the end of the day, you have a test. You have the SAT, you have, the AP exam, the IB exam, whatever it is. And you want to know which method is going to work best for you. And that's by creating an eval set. An eval set is just basically a giant test. Think of it like the SAT for agents. There's a ton of different evals for a ton of different domains. So you have like coding evals, you have information retrieval emails, truthful evals, you have like document summarization evals. Creating a good eval set is like the most important thing you can do to create an agentic system and bring it to production. With that, like everything else is like basically how you use it to improve the underlying system in general. So you can do things like improving, fine-tuning your model so that it becomes more stylized to produce results that are in line with what you're after. You can do prompt engineering, right? That was kind of the idea behind chain of thought and trees of thought, things, so on and so forth, which is you iteratively find a way to create the right prompts. And ultimately, you can use that to kind of like iterate and improve your agentic system overall. I'd say the most important part of the stack, though, it's just being able to add the logging and traceability. Two main reasons. Number one, understanding as a developer how your agent's able to work with things is the best way to actually improve it. Just having visibility, you're going to be reading through thousands of prompts. Understanding how that works is going to be key to how you, as an AI engineer, is going to develop the agents. Second is you can actually do a lot of interesting stuff with the logging data. So every LLM call that you do not save to your database is a lost LLM call. It's a leaky bucket. What you can do with these LLM calls, you actually fine tune cheaper and faster and more effective models just based on your inputs and your completions. So for example, AgentOps, we work with a provider called OpenPipe. What they do is they take 100 to 1,000 examples, and all it does is it just fine tunes very good, effective models that are 10 times cheaper than GPT-4 and like twice as fast. So, and just as good. So highly recommend just like adding an observability layer, doing that. We'll talk about a little bit more of that later. All right, so anyway, what are the biggest use cases? So the biggest 3 use cases we see in enterprise are text summarization. So basically talk with documents, chat, just like, being able to take long contracts, things like this, summarize it, huge use case. A ton of people in enterprise are using this. And that's why they have enterprise ChatGPT. Chatting with your documents is also a very big one. Just being able to understand like the formalities of how things work. Huge use case. And that's where the RAG applications come into play, where you have like very, very large data sets that you need to load in memory so you can chat with them. The last one is support Q&A. I wish I had a slide for this, but there's a company called Klarna. Klarna is a Swedish buy now, pay later company. So think of it like layaway, but on Rails. They had a support Q&A system with human agents, right? And what they ended up doing was they built an AI agent that replaced all of their support Q&A. Not only did they see they were able to eliminate 90% of their human agents, but they had higher NPS scores, or higher scores. People love talking with the AI agents. And on top of that, they're saving $40 million a year with these support Q&A agents. So huge value add to this kind of stuff in support Q&A. So with that said, all right. I want to show off
quick.
Yeah, go ahead.
Quick question. So Leon is asking, how do you get/make eval sets? How many evals do you need?
Fantastic question. So the first thing you need to do is decide what data set you want to work with. So if you're building a code eval agent, I'd really recommend checking out Hugging Face. They have a ton of evals and data sets on there. Looking on open source repositories, a lot of people are uploading those. There's no standard configuration. We'll talk about what standard configurations look like, but definitely check that out. If you're actually building evals, you're building an agentic system right now, definitely DM me afterwards. We have agent evals built into AgentOps. So I can actually show off what that looks like. Why not?
For sure. And
so here is so for example, we have like a testing dashboard on AgentOps. This is alpha, so kind of pardon the dust a little bit. But the way it works is that you develop configuration files. So this is an eval set called Web Arena. Web Arena is where we take these fake websites. So this is like a shopping admin dashboard, and we're hosting these websites. If you go here, you can send your agent. It's like a sandbox environment where your agent can like interact, type in the username and password, futz around with the dashboard, so on and so forth. And you give it the intent in your eval. So the eval might be, what is the top selling brand of Q1 2022? The answer should be Sprite. And in this case, the agent got it wrong, so it failed. It was supposed to do an exact match. But essentially, you can do with like a lot of other things. You can do fuzzy matching, you can do LLM matching, so on and so forth. And you can basically see like how effective is your agent at answering questions and actually performing actions. And this is like kind of the basic pattern most evals do, which is they have like a JSON or a config YAML file where you define exactly how you're supposed to execute the task and then how you evaluate it. So that's for evals.
Yeah, thank you. Second question is for me. You mentioned 3 common use cases for AI agents: text summarization, support Q&A. I missed the third one, but
yeah. Chat with documents.
Chat with documents. You got it. Because the chat with PDF repo like blew up and stuff, and PDF
Yes.
AI, big project. What are other common use cases or interesting ones that enterprises haven't explored yet that are possible with AI agents? So not your typical basic chatbot, support Q&A, summarization.
Yeah. My biggest theory is that RPA, which is robotic process automation, is going to be probably one of the biggest use cases. So I want to show off an agent called Multion. Let me figure it out. So Multion is a AI agent. And basically what it does is it takes control of your browser. Let's see here. Let's log in. Cool. All right. So we're in. So I can like give this agent like any task. Let's say reserve a table at Fogo, right? Which is a popular Brazilian restaurant in San Francisco. And what we'll do is like you have a chat bar here, and the agent actually reasons through how to solve the task. It opens up a browser, and then the agent actually intelligently clicks on elements in that browser to automate tasks. So you can imagine like a lot of work is just navigating through ancient websites. Sorry, right now it's going to Google. It's going to read the web page as images, as text, as HTML. Okay, now it's navigating. It's on Google. It's typed into the tab here. Yeah, it also talks to you, but sometimes it can be a little bit annoying. But it's very slow right now. That's like one thing. I like to kind of hammer home the point, which is agents right now are very slow, they're unreliable, and they're very expensive. So right now, okay, cool. It's clicking the link. Now it's on Logo.
And what would be the solution to that to reduce the cost and make it faster?
Hold on, it's talking to me. All right. So the number one thing is LLM costs are extraordinarily expensive, and that's because just again, it's going to become commodified in a way. But I'd say the solution is getting cheaper, faster, local open source models running on your agents. I would just say like eat the cost right now because accuracy matters more than everything. Reliability is the number one thing preventing agents from hitting the market. So yeah, that's what I recommend.
Gotcha. And we're booked for Fogo for tonight, or is it still figuring it out?
We'll continue playing. Let's see what happens. So, all right, and so one big component with these agents is they say, hey, let's say May 8 at 8 p.m. So there's like human in the loops where you can actually send agentic actions to humans. There's a interesting company called Payman, and what they do is they just every time an agent can't do something, they get a human to do it, clicking on CAPTCHA, entering credit card details, so on and so forth.
It sounds so dystopian when you actually talk about it. AI agents hiring people, but I feel like it could become normal at some point. Like 5 years down the line, people just like getting paid from like agents, and yeah, it's gonna be insane.
Yes, okay, I'm gonna close this because it's annoying me, but just talking. But yeah, anyway, like I think navigating the web is actually a huge use case. There's a lot of really cool companies working on this. Reworked is an agentic company, basically extracting web data at scale. So the idea here is like you can give it data on real estate or e-commerce stores, and just it creates these agents that scrape the web intelligently without any need for developer programming, and that's like a huge use case. Second to that, we have browser base. These guys are popping off recently. So it's kind of like AI agents for web browsers. Really, really interesting stuff that they're doing. I can think of a few other AI agents. I think kind of the most popular one right now is Cognition Labs, Devin. Devin is like for writing code. So the idea here is like you might add Devin to your software engineering team. And what Devin's able to do is like, find and fix bugs. All right. Labs on.
They recently did a hackathon too, I think, giving people beta access to Devin.
Yeah, I heard that. I unfortunately was not able to attend, but it looks super, super cool.
Yeah, because I feel like if you were there, you would have live streamed the whole demo day, so we would have
might
all
have done
experienced
that.
it.
If you got the hookup, let me know next time. There's a lot of cool hackathons I don't get invited to or I don't know about, so always happy to kind of blast those out.
Yeah, for sure. Could we hypothetically, or it's probably done now, integrate Devin to MetaGPT to code better and faster, or tie that with other chains to self-check and self-evaluate?
So are you asking, could we give Devin access to MetaGPT to make MetaGPT better, or?
Well, that one, and also just improving MetaGPT, 10xing its coding powers.
Maybe. I think that like your ultimate limitation with LLMs in general is that they're basically stochastic parrots. They're reflections of the world model. So they're only as effective as how good GPT-4 is at understanding code. So one thing I think a lot of people underrate is that most of software engineering work is not dealing with existing tools and stitching those together. And that's what MetaGPT and Devin do quite well. It's actually about taking new tools or tools that you develop yourself and then figure out how do you chain those together to make things that are interesting. And so those are like kind of the biggest complications with these coding agents. Like they don't understand code that hasn't been written yet prior to checkpointing the models. So I think hypothetically it's true. I think Devin can probably make it work. The biggest advance in Devin in my book is actually the Devin interface. I think the reason why Devin was such a huge drop in the programming world is that they have look at this UI. It makes so much sense, which is like you have your terminal in the top right, you have your code notebook in the bottom right, you have the web browser in the bottom left, and then you have like the reasoning engine in the top left. And it's so clear and concise exactly what it's doing that you're saving just like a ton of time and effort. So the UI layer, I think, is probably one of the most underrated side of things of how agents should be operating.
Right.
They're tools for us. They're not tools for robots.
Yeah. So that's the thing. So most of these tools are kind of doing the same thing, but it's just like the UI that could differentiate them, or maybe the reach, the marketing drops, to how they could stand out.
Oh, can I drop you? Hello?
Oh no. Can you hear me? Also, this kind of looks like what Replit AI is doing. Side note, we might be doing a workshop with them tomorrow too. But is there like something super cool about Devin's UI that makes it stand out so much, or is it like VS Code and like steroids or something? But what's like the thing that you say like Devin is the thing that you want to use for coding?
Two main things. Number one is I think it's the simplicity of the design that they really did nail. It's a great looking design. They figured it out. But second to that, they actually have kind of like checkpoint debugging. We actually in AgentOps have a time travel debugging feature. We'll talk about it in a little bit. But the idea here is like being able to rewind your agent to a checkpoint and then restart it from that point is a huge value add. Because I've heard some folks who are using Devin and they were running things for 9 hours, right? They're very, very slow and very expensive. So if you want your agent running for 9 hours, there's a likelihood that it's going to mess up somewhere along the way, fall in a circle, and you want to modify the parameters so they can get back on course. So that's where the kind of the main the value adds are: UI and time travel.
Sounds good. Yeah, let's circle back to Agent Ops, because this is not a workshop on Devin. We could do a separate one with them. But yeah, you mentioned you wanted to like showcase how to make an AI agent live with Agent Ops.
Absolutely. So let me. I am going to let me unshare my screen. How do I do that? Okay. Oops. Okay. Stop screen. Cool. I am going to put a link in the chat. Everyone will have access to this repo. We have taken some Crew examples from Crew AI and just made them easy to access with Agent Ops. So, and I'll show you how to run them.
Perfect. And is the link on Twitter under the live stream, or where do you share it?
I have just posted it in the chat right now.
Private chat. Okay, perfect. I can post it on YouTube and go and put it on Twitter as well.
Excellent. Very, very good. So, all right. What I will do now is I will do some live coding. Give me a minute here. I'll set up a new desktop.
To take your time. We had a live stream, I think, with it was either AVK from Neo4j or somebody else, and we were chatting about this idea that if folks are live streaming live, there should be like an AI privacy checker that blurs your private keys and stuff, because you don't want it to be leaked, right? So that's something that people could potentially build. I don't know how feasible it is, because you have to like integrate with OBS or Zoom and stuff. But that'll be a cool thing to see as well.
I have leaked keys before, and I've lost hundreds of dollars. So just be mindful.
That's a shame. That could be like the problem statement, the quote. Alex loses $100 with leaked API keys.
Cool. So what I will do now is I will open up a terminal. I have gone to the Crew AI examples repo. It is a fork on the Agent Ops repo. So what we're going to do is let's make a new folder. I will zoom in a lot, and I will do make clear crew AI agent ops crew AI. All right, so now I'm in my directory. I will git clone the repository link I have posted. Copy.
Sorry, did you want me to put your screen up on there or not?
Oh, am I not streaming?
No, okay, yeah. I just added now. Yeah.
Okay, sweet. All right, so everyone, check out the link if you want to follow along. Otherwise, I will just do it live in front of everyone. We have a repo here, Crew AI examples. It's a fork of Crew AI from the Crew AI project. And we have plugged in agent ops into this, so you can actually see how to run this. So I will clone it. Okay, and then we'll cd to Crew AI examples. The one we'll play around with is the job posting. So I'm going to cd job posting, and let's open it up. Okay, job posting. So what job posting.py looks like is we have, let's see here, main.py. Let me zoom in a lot so you can see it. Okay, so the way that we set it up is, first of all, if you're building agents, like I'm showing this because it's my company, but I also think that you get a lot of value just by like not looking at logs in terminal. If you run agent ops, all of your logs and all of your LLM calls and all your actions will be logged. So we set up a client with agenops.init, and that's basically all you need to do to get your agent ops plugin with Crew. So we'll say job posting, and then we'll say the job is for agent ops, right? So the idea here is like, we will create a job posting for agent ops. And what we're going to do is we're going to have a few input variables. We'll have the company description, and we'll say, what is the company description? Company domain, what is the domain of the company? What are the hiring needs? And what are specific benefits you offer? And we're going to kick off 3 individual agents. We're going to have a research agent, a writer agent, and a review agent. So to create an agent, there's this agents.py. There's a class called agents. And that's where we define these things. So underlying it all, we have this agent class that comes from Crew AI. Basically, all you have to do is provide it a role and a goal and the tools. So the research agent, for example, we want to be able the ability to use Google, so SERPer, and the web search. The writer agent also has these tools, but also has the ability to read files. And then lastly, the review agent, its job is just to summarize and clarify and make everything grammatically correct. And has all the tools and the ability to read files. And it's just going to print things out at the very, very end for us. So that said, all we have to do is add these agents to the crew. So we say the researcher agent, the writer agent, and the review agent go in here. We define a set of tasks. So this is kind of like the planning mechanism that Crew AI uses. Again, there's like a lot of different ways to plan agents around stuff, but here's how we're going to be setting it up. We're going to give it the ability, see task.research, task.py. So task.py is we can define a bunch of tasks here. Tasks are also a class from Crew AI. Task 1, analyze and provide a company website and the hiring manager's company domain. And here's the description. Focus on understanding the company's culture, values, and mission. Identify unique selling points. Awesome. Another task. This will be for the role requirements. Based on the hiring manager's needs, identify the key skills, experiences, and qualities the ideal candidate should be using for the role. Awesome. Expected output, this kind of stuff. And then we define the agent as whatever agent we pass in. Drafting a job posting, same deal. Reviewing and editing, same deal, so on and so forth. And we're going to pass all these tasks into the task queue. And the task queue will just be defined in the crew. So we have the crew class, we have the agents, we have the tasks. And then all you need to do is run crew.kickoff, and then it all works all by itself. So with that said, let's run this. So first thing we're going to do is .env. We are going to give it an agent ops key. So number one thing is I'm going to comment this out because OpenAI key is in my environment right now. And I'm going to keep out SERPer. Let's see here. I will get an agent ops API key. Let's do that. So open up a new window. What I recommend everyone do is you go to app.agentops.ai and you simply, when you log in, you go to your projects tab. And you can see all your projects in here. We're going to create an API key. So I'm going to go copy my API key from here, copy it. Good, we're on keyboard or on clipboard. And I will just give that here. And sweet, we are in. The parent key is actually, if you have an organization, you can actually attach, everyone in your organization can see your runs. So for example, if you want to share your runs with your team, you're able to do that by sharing a parent's key. We have main.py, and we should be good to go. All we have to do is create a copy of that. Copy example. Excellent, and we're in. So I think the server thing will be fine, but we will see if it fails. And then we're going to create a virtual environment. This is everyone's favorite part. venv, env, and then we'll source activate it. Then lastly, we will pip install -r requirements.txt. And that will install all the stuff. It will install Crew AI for us. It will install Agent Ops for us, and we'll be good to go. So let's give that a minute. Do we have any other questions in the chat while I download all the dependencies? Okay, I guess we're good. All right, so anyway, I have a preloaded run now because I think this might take too much time. So let me run this guy. Where is my job posting? Oops. Yeah, so this is a run that I have preloaded. We will run this guy. We'll say Python main.py, and we will give it the job that we want it to run. All right. Oops. One more time, let it run. All right, company description, agent ops, builds, observability, testing, logging, and debugging for AI agents. Spelling is fine with agents, by the way, because large language models are by and large quite smart. We'll say agentops.ai. We are hiring an AI engineering expert who has worked with agents and knows a lot about RAG, vector, databases, and React.js, just for say. Specific benefits. Benefits is work on cutting edge research and build cool projects. Okay, now what's going to happen is the crew is going to kick off. And what we can see here is that we have the agent is going to start scraping the web. It's going to start scraping agentops.ai. It's going to print out a bunch of stuff in the terminal. And this is how it actually reasons through all of its tasks and problems. So we have agent ops, make your agent works, blah, 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 blah. I'm going to go to the website, look at their values, their perks, their benefits. This is actually launching a headless browser that searches the web and defines exactly what the stuff is going on here. This agent run itself actually takes a very, very long time. It might take maybe 5 to 10 minutes. So I will show you a pre-cache run that I have on agent ops. Let's see here. All right, great. So on agent ops, you actually have the ability to see all of your agent runs in a dashboard. So I can see exactly how much money I've been spending, my average cost per session, the number of tokens per session, the number of tokens in failed sessions, so on and so forth, but also be able to kind of more granularly see which sessions have been failing and drill into those. So at a high level view, like most of my agents kind of suck. I've had 70 failures, 43 successes, and then 12 that never actually completed. And so the idea here is I can actually see at high level how my agents are performing over time. I'm going to go into my session drill down chart here and look at my agents that have been running. So let me do this. I will go to sort this, descending. Cool. So here is an AI agent that I've been running. I've run in the past. It took 6.5 minutes and cost me $2.67. And we can see all the information that we talked about in the PowerPoint is in here. So the host environment, I'm not running in a sandbox. I'm running on my laptop. See, I have 16 gigs of RAM and I'm on Python 3.11. And we can see that I actually finished the execution during the run and I consumed about 80,000 tokens while I was doing so. The interesting bit here is that since we actually ran 3 agents concurrently, we had we can actually filter through. We see we have a research analyst, a JD writer, and a review specialist. And we get a whole LLM call summary here. So instead of having to scroll through the scroll through all of this kind of stuff here, right? You know, this is unbearable. You can actually see all of your logs saved in the dashboard here. So I can see step by step how the agent is reasoning through problems. So this is all the agents. But what if I just want to say the research analyst, right? I can actually filter through and see which calls the LLM was making, which tools it was using, so on and so forth. So for example, here, my job description writer actually used 7 tools, talked to CB Insights, talked to a number of other tools, and was able to basically collate them all into a single prompt. I'm going to show all of them. And then lastly, what we can get out of this is a session drill down or a session replay where I can see every single step that the agent has made during the execution flow. I can see all the LLM calls, all the tool calls, so on and so forth. So for example, here I had GPT-4 spend 2 cents to basically evaluate the prompt that it was given. So you're a research analyst, you're expert, you research company culture, values, so on and so forth. And here's your job, right? Blah, 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 a lot of text. But I can also see that I was instructed to search the web, right? So you can see the tool call here, search the website. And basically I can trace back exactly what was going on and actually debug which LLM calls took the most amount of time. So for example, this one, it was a 17-cent API call to OpenAI. We can see that it was actually a lot chunkier than the other ones, just in terms of like the number of prompt tokens that I fed it. So that's some information here that we could use to say, okay, maybe this prompt could be condensed in some sort of way. We could save a few cents on the execution. So in any case, that's basically how we run Crew AI agents. Anyway, that's the key demo things. The way that you work with AgentOps, by the way, if we go to GitHub, if you're interested in either using Crew AI is pretty baked in. We will send a link to the branch there. Just follow the documentation page. We have some Crew AI integration examples. But secondary to that, all you have to do is import AgentOps into your Python script. You do agentops.init, and then you actually just add some sample recorders. And then all that information will get saved to your dashboard. Yeah, anyway, so that's the demo. We can also run some other agents, try to debug them live, if that makes sense. Otherwise, we can kind of do freestyle Q&A, talk about all sorts of stuff.
Perfect. Thank you so much for your time, Alex. This was super helpful. I learned a lot. If it's possible to get like a copy of the deck, because some people ask them for it. I mean, the live stream is there. People can go through it, but if it's okay, we'd love to share the deck with them too.
Gotcha. I will figure out how to make the deck shareable and share the deck.
For sure. Yeah, you do that. Also, if anyone has any questions, put in the comments, LinkedIn, YouTube, Twitter. While we have Alex, we could ask him. On that note, while I have you here, because I know you're super busy, Chief Vibes at Cerebral Valley, love to have you as a community partner as well. I'm trying to secure a location in SF, the residency by Nick, and I forgot the other co-founder's name, to have people coming in person in their hacker house for the hackathon, May 10, 11, 12. So would love to have it Vancouver, London, SF, and virtual. It's one of those things to remember.
Awesome. Hi, by the way, if you were in San Francisco, if you definitely check out the residency, super cool organization, but also Cerebral Valley, I'll put the link in the chat, has all the links to all the events. .ai. So basically, they're a link tracker of all the cool things that are happening in San Francisco, hackathons, meetups, events. I think that your event's probably on there as well. Or if it's not, I can help get that on there.
I hope it is. I think somebody from the team submitted the form, so somebody has to check that. Either that's you or somebody else.
Cool. I will make sure that gets bubbled up. But,
perfect. Sounds good. If there is no more questions in the chat, we could end the call right now because I know you're super busy. We gotta let you go. Some promo for a YouTube series we're thinking of is having you from Agent Ops and a complementary tool to create a app or project live on the spot. So say you use Agent Ops, you show people how to integrate it with their tool, like I don't know, Pinecone, for example, and then we do like a mishmash of hands-on working, and this could be like a repetitive series, right? Of like Agent Ops times X, Agent Ops times Replit. So I feel like that'll be super interesting for people to watch because it's, the deck is nice, the coding session perfect, but if they actually see you're making something in like 1 or 2 hours, then they'll be inspired to be like, oh, I can do this in 1-2 hours if Alex is doing it.
All right, Brad, I'm happy to do code alongs. I will come up with some repos that don't take as much time to install, and we can basically jam on that. It sounds super fun.
Perfect. Sounds good. Thank you so much for your time, Alex. Once again, this was the workshop part of the Be Loud and Build hackathon series. We're partnering up with Agent Ops, and we'll add the event to Cerebral Valley. Do check it out. And thank you so much again, Alex, for taking the time to come on.
All right. Adios.
Yeah, thank you so much. It was great.
Okay. Thank you. Thank you so much, everyone, for coming over. If I'm gonna try to get Alex to share the deck, minus all the private info and blurring all of it. Do check out the hackathon. Nick, people know about the residency now. They might come over to your place, regardless if you want it or not, for the hackathon. So be prepared. Yeah, if you do want to join, go for it, and we'll be happy to support you. Do let Alex know if you have any follow-up questions on it. If you want other workshops, let us know. We're doing one with Replit tomorrow. We're doing another one with Nexus GPT, possibly Crew AI, TBD. So let us know. And thank you so much for tuning in. I'm Poria from Be Loud.
Okay. And I'm Bahar, co-founder of Be Loud. Thank you so much for coming here. Please share us feedbacks, comments that how we can make these workshops better and what are the topics that you would like us to share. And don't forget to sign up for the hackathon. It's both virtual and in person, so it's accessible for anyone who wants to join in. And it's 3 days of building a startup. So love to see what you can come up with and what you can build in 3 days. And I think we can end the live.
Yeah, thank you so much for tuning in. You take care. Have a wonderful day. Bye-bye.
Bye.